everyone, my name is Viraj and welcome back to my channel Data Crafts. I hope everyone is doing great out there. So for today we are going to dive into a very fascinating SQL problem, and for this problem we will be calculating the total uptime of servers. So let's get started. The question states that we have a table called servers, this one, and we have three columns, that is server ID, status time, and session status. So all three included, that is server ID, status time, and session status is the primary key, and the session status is enum, that is the values in that particular column would be fixed, that is start and stop. We need to figure out to find the total time when servers were running, and the output should be rounded down to the nearest number of full days. So how do you solve the problem? So for this problem, you would be using the timestamp, using the sum function, using the floor function, as well as the common table expression to solve the issue. The first thing what you could do is you could just what say group all the servers like 3 3 3 4 4 4 and like whatever, and like order it by the status time and session status, then give each row a new identity, that is row number or dense rank or like a normal rank function, and you could lag the function, and like you could lag the rows and then subtract the status time. So I tried to solve using that method, but it did not work in that way. So I'll just tell you how to solve it. Okay. The first thing is I would be selecting all the rows from servers. Then using the lag function, comma lag lag function, I would be lagging the status time. I don't need to like what I say partition it. I just need to lag by every row, like every record, as pt. Okay, I run it. Sessional. Okay, got it. This works pretty well. Yep. Let's name it as something common table expression as. Then what I would be doing is uh, so here's the thing, we are getting an output with a lagged column. You could see over here, this one, and if you could see that every server ID star like there are two consecutive rows like with start and stop. You just lag it and you are getting one record for every session status called stop, where it has been started over here and the ended over here. Just subtract that one and you would be getting a solution in minutes, and then you could convert it in hour and a day to get the final solution, that is a total time. So like I was trying to figure out whether there is a way that we could partition based on every server ID, but that actually doesn't work. I could show you how what the problem causes over here. So if I remove the let's say common table expression and partition by even server ID, it doesn't work that way. Yeah. So even though it comes like you could see over here 1 1 1 1 1, but there are certain rows where there are like there are certain two or three consecutive rows where the session status would be start and start and stop and stop. So for that those rows there would be a difficulty for trying to figure out what exactly like when do you consider the start time and the end time. Rather, you just lag it by one row and subtract it. You are getting the whole solution directly. You don't need to fidget it a lot or rant upon how you get the solution. So you don't need to do this thing, partition thing. Like for certain cases I tried that solution but it doesn't work, so that's the reason why I just use a very simple way. Lag it by one row, then what I do is select server ID. I won't be needing the session status, And if you could see over here that for the status time, if you have lag, then like just use status time, that is the end date, end time, and pt, that is the start time. CTE, run it. Oh, okay. So see, this is the original table, and in the original table, you could see that we are just lagging it by one row, one record. That's the reason why we are like for every record you could see this one. Now the other thing is just filter it by the session status. Like, see, we need to just subtract these rows, right? The start row, the that is a start time and the end time. Just use these rows for that reason. You don't need to use the start like session status start these records. Just filter it out. Perfect. Yeah, this works pretty well. Now I won't be needing these columns. You could directly use the timestamp difference. Now what exactly timestamp difference do? Like, first I will write what is timestamp. Okay. And yes, we are getting the total time. Now the next thing is we need to submit, because what the question says, we need to find the total time when the servers were running. Like, we don't care like which servers were running, like it's 4 2 1 5 whatever. We just need to calculate the total time, and by differentiating the end time with the start time, we are getting the total time run by each server. And the next thing is I would be summing it up. Use the same thing. You don't need to like build another uh what say common table expression. Just do it on that way. Yeah, so this is the total uptime in minutes, not in days. Now divided by 60 and multiplied by 24, we would be getting in days. And just multiplying it with 1.0, not causing the int by floor thing. Yes. So this is the total uptime days. Now the output should be rounded down to the nearest number of full days. So I was trying to figure out like whether to use a round function or floor function or ceil function. So in this case, like for this particular problem, we are using the floor function. What does floor function do? Even though it is 11.94, like let's say 11.45 or 78, the floor function, that is this one, floor of 11.7 would be 11. Floor of 11.2 would be 11, right? And the ceil function, the ceil of 11.2 would be 12. Same goes for 11.89 would be 12. So I figured it out that even though you use a round function, it doesn't matter for like it would show like we need just 11 for this purpose. So that's the reason why I use the floor function. I think so there must be a um typo in the question. They should have stated it very clearly, but no, I don't think so. They have stated it properly. Yeah, it worked out pretty well and submitted. Yes, our solution worked and it like beats 79%. Previously it was 86, but yeah. So first thing, why we have used the timestamp difference. So timestamp difference functions is to get the difference in minutes between the current and the previous status time. And then what we did was sum up those differences over here. Yep, this sum up those differences and convert the total time into days by dividing it by 60 into 24. 60 into 24 is like converting the minutes into hours, then dividing it by 24 to convert it into days. That is the total uptime days. That's all. And finally, we have used a function floor like to round down to the nearest full day. So that's how we have solved the question. I hope you did understood the problem, and if you do like the problem, just do let me know. Like if you like the problem, just solve it yourself. You will get an idea how this problem works. And if you need to understand more solutions, go to the solution like session over here in the navbar and just watch how other people have solved it. Like, Oh, they have used a unique timestamp. Nice. This is good. This is bad. Too complicated to understand. But yeah, just do it yourself. And if you find it difficult, just comment it down. I would help you out how to solve the problem. And yeah, if you do like my solution, please hit the like button, subscribe button, and comment, and do share it. And be safe, be happy. Till the next time. Thank you.